I will not be talking very much about GIS at all. I'll be talking about all kinds of IT, system architecture, software components, putting them all together. So hopefully you're in the right room. If you're not, you're in great company, though. It's a big crowd, and I'm very happy to see you all here. I'll give it just another couple of minutes to make sure that we get everybody set up in the overflow room. And for everybody who can't see the presentation here in person, I apologize. My bad jokes are much better in person. We'll see how that works out. So if you came here to this session because you couldn't figure out where the previous version of this session was, it was over in the Hilton. It took me a little bit by surprise when I checked my calendar and where I had to go. So that was all good fun. I'm glad you're here. This is the second version of this presentation. The other one was here at 10:15. So this is what I'm doing today. This is my day, talking about architecting your deployment. My name is Philip Heedy, as it says here on the slide. I'm the Senior Product Manager for ArcGIS Enterprise. I also like to joke that I used to do real work. I have a background in professional services. I do know how to push the buttons, hence why I'm talking about things here at this session. So let's get started. I'm glad most of you raised your hands on the system architecture, IT administrator side of things, because that is really what I'll be talking about here this afternoon. I have a number of fairly hard prerequisites in the sense of I will not be covering the basics of ArcGIS Server, terminology, things like sites. I assume that you know what an ArcGIS Server site is. I assume you know about some of the basics of the different software components. So my ideal persona for you in here, which I think many of you meet, is somebody who's doing system architecture and needs to understand the different software components that go into ArcGIS Enterprise. For many of you, that means that you already know about things like the web adapter. You've heard about that before. You know what ArcGIS Server is. Bonus prerequisite is if you also are familiar with Portal for ArcGIS. So for those of you here in the main room, how many of you have familiarity with Portal for ArcGIS? Show of hands. Why are you even here? No, that's okay. Hopefully I can still teach you something about the different software components, how we have architected them, how we imagine them being put together. Now, this is a medium to advanced level session, I would say. There's a lot of content that I will cover. I will go at a fairly rapid clip because I want to get through all of the content. If you want to take pictures of the slides, that's perfectly okay. However, if you want the actual slides, come give me your business card after the presentation. I'll be happy to give you the slides ahead of time. The slides will also be posted on the conference website with the proceedings in due time. If you want them even faster, give me your business card and I'll make sure to get them to you. So, medium to advanced level session, lots of information, rapid fire, keep up. Now that I've scared you, don't panic. Hopefully I won't overwhelm you. That's not my intention. There's a lot of content on the individual slides. These are not your slide where pretty ones with a picture and I talk to it. I intend for the slides to also be able to be used as a reference in many cases. So if the slides are a little bit text heavy, that's somewhat intentional. I want you to be able to take them with you as you go back home to your organizations and work with these things. Please don't panic. We'll get through this. So what I will be talking about here today is a single ArcGIS Enterprise deployment. I won't be talking about the desktop GIS patterns where it's primarily centered around things like ArcMap or ArcGIS Pro. Whether you're using those individually on desktops, maybe connected, maybe you're sharing shapefiles or file geodatabases through whatever means. That's not my intention. What I also won't be covering is what I have termed server GIS, the more traditional ArcGIS server implementations. I'll talk about how that relates to the modern ArcGIS Enterprise product. So I'll hopefully give you enough information for you to understand how the product's evolved and how you can move from where you maybe are today to the newer deployment patterns. So I'll be focusing on what we lovingly term the Web GIS pattern, meaning the full ArcGIS Enterprise stack. It's not just server, there's also this portal thing, but many of you are already familiar with that, so that's a good thing to start from. I also won't get into distributed GIS. You heard Jack talk about this at the plenary on Monday. That's this idea of connecting many systems, a system of systems, if you will. You've got multiple ArcGIS Enterprise deployments. You may have ArcGIS Online organizations, and you connect them up. I'm focusing on the individual ArcGIS Enterprise deployments. That forms the basis for, if you want to later on connect them up to others, you have that in place. But I'm talking about how to architect and scale that individual deployment. All right. So what is ArcGIS Enterprise? We did something. We changed the name. Maybe that's why you're all here. You're wondering, if they changed the name, did they also change the software? Do I need to do anything? Can I upgrade? It's going to be hard. I'm going to tell you, no, don't worry. ArcGIS Enterprise is the product that contains a number of different software components. The 4 components that you see here. There's ArcGIS Web Adapter, there's Portal for ArcGIS, there's ArcGIS Server, there's ArcGIS Data Store. Now, one of the parts of the ArcGIS Enterprise branding that you'll start seeing more and more is that when we're talking to end users, somebody who's consuming services, content, items, data, whatever it is, from ArcGIS Enterprise, we will be de-emphasizing the individual components. Because why would we talk about the individual software components to an end user? You care about them. That's why you're here for this session. You know that there is such a thing as Portal for ArcGIS because you had to install it. You had to figure out how big a machine to put it on, whether to do high availability and so forth. But just like the common user of Outlook probably has no idea that there's such a thing as an Exchange server on the back end, the users of ArcGIS Enterprise shouldn't have to worry about or be exposed to the fact that there's all this detail. That's for you guys. That's why you have interesting jobs. At most, the Outlook user will see an error message every now and again when I couldn't contact the Exchange server, and they have no idea what that means. Every now and again, there might be a bleed through in an error dialog that says, well, Portal for ArcGIS couldn't do this or that. Hopefully, we can minimize that. So more and more throughout our documentation and the different applications, you'll see references to ArcGIS Enterprise or the ArcGIS Enterprise portal, as opposed to references to individual components. That's very intentional. That's not because we're trying to minimize what you're doing, but that's simply because we're talking to a different audience. And we want to have a simpler story. So one of the places that you see this very often today is when you log into Collector. First time you bring up Collector on your iPhone, it asks you to do something. It asks you to log into the system. It asks you to log into what? ArcGIS Online or Portal for ArcGIS. That's going to start changing. As all the different apps start updating, you'll start seeing the option being log into ArcGIS Online or ArcGIS Enterprise. It's going to be a transition, so it's not a big bang. We're not that coordinated. We have different release cycles, documentation, lots of different things. This will take a while. But as you see that starting to come in, don't be alarmed. We're not trying to say that Portal for ArcGIS is going away, but we want to have a better way of talking about things to the right people. However, for the rest of this session, I will be talking about nothing but the individual software components. And you'll notice something. You've heard about all these before. These all existed before 10.5, right? You've all worked with ArcGIS Server. Great many of you have worked with Portal for ArcGIS, which means you've probably also heard about the data store and so forth. So that's a good thing. Some of the new things that I'll talk about is the pattern of deployment, the base deployment architecture, and how to scale and go beyond from there with adding additional capabilities. So let's get on with that. But first, a detour. Something else we did at 10.5 along with the rebranding to ArcGIS Enterprise as a whole, we introduced something we call server licensing roles, or in many cases just server roles for short. In the past, you installed ArcGIS Server, forget the for, and then you licensed it at the basic, standard, advanced level, and then you could add extensions on top of that. You could add network analyst extension, GeoEvent extension, image extension, many different things. But they all the extensions build on top of that core foundational capabilities. One of the things we did at 10.5 that I won't get into too much detail about, except as how it relates to architecture, is we decoupled some of that functionality from each other. Some of the things that used to be extensions are now server roles in their own right. So what in the world does that mean? It means we have a single software component. You install ArcGIS Server, lays down a bunch of bits on disk. But it doesn't do anything until you actually apply a license file to it. And now when you apply a license file, you apply a license file with a server role. The primary server role that you all think about is the GIS server role. You can think of that as traditional ArcGIS Server. It exists in a basic, standard, and advanced level. And it does all the things that it used to. The GIS server publishes map services, feature services, geoprocessing, so forth. And there's still extensions on top of the GIS server. Network analyst as an example. What's new is that we took some of the extensions, specifically GeoEvent and image extension, and made them server roles by themselves. GeoEvent server instead of GeoEvent extension. Image server instead of image extension. And the reason this matters for the purposes of architecture is that we're trying to align the business model, how you purchase capabilities, with how we actually tell you to architect. Because an extension implies that I want the capabilities of the core thing, and then I want some additional stuff on top. But in many cases with GeoEvent and image, the IT best practices were really, well, you should have dedicated infrastructure for it. Don't mix your real-time processing with your map services. Well, that doesn't really work. Why am I adding an extension on top of something I shouldn't then actually use? Well, we agreed. So we've changed that. That means you can now apply a GeoEvent license without having the GIS server piece in place. You've installed ArcGIS Server, that's software, and then the capabilities are decoupled. So we'll talk more about what that means here in a second. The key point here is that there's one software component. When you install ArcGIS Server, you now have to think about what capabilities are you actually lighting up within the ArcGIS Server install. The name of the GIS Server was intentionally chosen to be very similar to what you think of as ArcGIS Server from previous releases. All right. So let's dig in to those 4 software components in more detail. With ArcGIS Enterprise 10.5, we introduced a new concept that we call the base ArcGIS Enterprise deployment, or just the base deployment, as a way to be more prescriptive about how we want the system to be built. How to take the 4 software components and stitch them together into the minimal system that provides a core set of capabilities. We call that the base deployment. And it consists of a combination of all 4 of those software components in a certain way. And what are the purposes of the different software components, just so you understand what ultimately makes up an ArcGIS Enterprise deployment. First is, of course, ArcGIS Server itself. That is still a core part of the product. It's where all the computationally heavy stuff actually happens. In the base deployment, ArcGIS Server has a dual purpose. It's a GIS server, meaning it does everything that traditional ArcGIS Server did for you. You can still publish map services coming from your file geodatabases, enterprise geodatabases in Oracle, SQL, whatever it might be, and heaven forbid, shape files. You all know you do it. At least some of you. But on the other hand, it's also what we call the hosting server. A part of ArcGIS Enterprise and the idea of introducing a portal to the product is that you can also allow your end users to do self-service mapping. And what does that mean? Well, one aspect of self-service mapping is that you've got your users that are making use of all the layers, the maps, and so forth that you've created, but they may be mashing it up with data that's otherwise locked up on their desktops. They can drag and drop a CSV file with a bunch of addresses or points, whatever it might be, onto the map inside of the portal map viewer. And, well, where does that CSV file go? How does it get hosted out? Where's the REST endpoint? Well, ultimately, it has to go somewhere. The REST endpoint comes through a service that is coming from the hosting server. Ultimately, there has to be a machine running something somewhere that gives you a URL that spits out JSON. So the hosting server is that thing. The next component is Portal for ArcGIS itself. Portal for ArcGIS, for you who are doing system architecture, I think it's valuable for you to understand a little bit more about how we think of Portal internally. Portal for ArcGIS is two things. One is the web front end. That's what most people think of when they think of the portal. Go to a website and you can log in, there's the map viewer, you've got your content management and so forth. But Portal also provides all of those back-end services that the application infrastructure, if you will, that everything that we've built, business partners have built, and that you build using our APIs and SDKs sit on top of. The group management, the identity handling, and so forth. That's all being provided by the portal side of things. Next one is the ArcGIS data store. And it's an ArcGIS managed data repository. What do I mean by ArcGIS managed? Well, again with the example of the CSV file. It's being hosted out of the hosting server. That's where the REST endpoint is. That's fine, but where did the data actually go? Well, it went into ArcGIS data store. We have to have somewhere to put it. So think of this in some ways as an enterprise geodatabase that happens to be embedded within the system itself. You don't have to do anything. You're not supplying your own SQL or Oracle or anything like that. This is a purpose-built database for use by the system internally. It's optimized for our purposes. We know exactly what it is because we're shipping it, and you're not doing any of the management of it. Is this a replacement for your own enterprise geodatabases? Absolutely not. It's a common misconception, and I want to get that out of the way. It's not. It's simply not intended for that purpose. When you give us some data that goes into the system, we have to have somewhere to put it. That's where we put it. When you run an analysis from within the portal map viewer, you hand over some data, you do some analysis. Where does the result get stored? We're not sending back a file geodatabase to you. What we actually do is now there's a hosted feature layer. It becomes available as a service that you can access. Well, again, that data has to go somewhere. So this is for the purpose of data that you hand over to the system or data that the system generates in response to your analysis jobs, your actions within the system. Your own enterprise geodatabases coming from Oracle, SQL, Postgres, and the list is long, stays exactly the same as it always has been. That's where you're managing your authoritative data. And you can publish that data as map image layers. That's a fancy way of saying map services. And everything else that you've been doing for years. And we want you to continue doing that because the two things are very different. They're two different workflows. Well, so ArcGIS data store is actually a little bit more complicated. That's why it's the don't panic. There's three flavors of ArcGIS data store. There's the relational data store, there's the tile cache data store, and then there's also the spatio-temporal big data store. And just like with ArcGIS Server, there's a single software component that can do a bunch of different things. There's a single install. There's a single software component that you can configure to have one or more of these different types of data stores running. Part of the base deployment is the relational and the tile cache data stores. So the relational data store, that's that enterprise geodatabase within the system itself. Think of it like that. The tile cache is not for raster tiles. It's not for traditional cached map services. It's for 3D visualization caches, 3D tile caches. So when you're publishing your multi-patches, point clouds, and whatnot, we build a visualization cache. But instead of writing bundles on disk, like we do with traditional cached map services, we're writing it to this purpose-built blob store. Spatio-temporal we'll get back to. And then finally, the unsung hero, the web adapter. It's a software load balancer, reverse proxy that we've built. It simplifies a lot of configuration pieces It's also the integration point for certain types of security. How many of you use integrated Windows authentication, for example? You're using the web adapter, right? That's how we're hooked into IIS and letting Windows do all its thing. If you're using the Java web adapter, we have similar hooks into Java application servers, LDAP, and so forth. All right. So what does all that mean? Well, a typical setup of ArcGIS Server today probably looks something like here on the left-hand side. Got a server. You might have multiple servers in a single site, and then a web adapter in front. It's a very classic, typical setup. The base deployment of ArcGIS Enterprise, by comparison, looks a little bit more complicated. There's a few more software components in there. That's okay. Don't be scared away by that. There's 2 web adapters, a web adapter for the portal, a web adapter for the hosting server, and then there's ArcGIS Data Store sitting down at the bottom. So that's the foundational or base deployment of ArcGIS Enterprise. That server there in the middle, the GIS server set as a hosting server, does everything your server from the past did, plus serves this additional role of where data goes to be hosted out of when you've turned it over to the system. So let's dig into that some more. How do I actually set up the base deployment? What are the actual things that go into it? Well, this is the logical architecture, and we talked about this a little bit. We've got the web adapters. They're hooked up to their respective components, one for the portal, one for the server. The portal itself is that web front end, but also the API back end that powers all of our applications. The server, well, serves those dual purposes. We'll get back to that later on as we talk about scaling out the base deployment. You can split things apart. You can add more resources. There's lots of different ways of slicing this depending on your particular workflows and needs. And then we've got the ArcGIS Data Store. So you'll notice that the data store is always connected up to the server. Data store is not connected to the portal. These are the internal details, things that you need to be aware of as you're setting up the system. And then, again, slightly different way of looking at the linear layout from before. In the base deployment, we have the relational and the tile cache data store types. All right. How many of you read the documentation whenever there's a new version released? All right. More than I would have expected. One of the challenges, and I truly sympathize with this, is that when a new release comes out, well, we've been working with ArcGIS Server for years. How much could possibly have changed? Well, I highly encourage all of you to go to the 10.5X now, 10.5.1, documentation to the ArcGIS Enterprise section. It's a new piece that came in with 10.5. And it outlines many of the things that I just talked about. It talks about the base ArcGIS Enterprise deployment. So it's your reference to some of these things. This is new. This is a brand new content that didn't exist in prior releases of the doc, and it's something we will keep expanding on significantly in the releases to come. We want to provide a lot more prescriptive guidance on how to do many of the things that I'm talking about here today. So please go check out the 10.5 doc. One thing I didn't ask before the session started was what versions people are on. This is one of my favorite parts. So for those of you in the room, by show of hands, I'll do this quickly. How many of you have upgraded to 10.5.1, released 2 weeks ago? One person in the back. I did a session yesterday, and I swear 10 people raised their hands, and I almost had a heart attack. How many of you are on 10.5 from last December? Excellent. 10.4X, 10.3X, good. 10.2X, all right, 10.1. Coming up on the end of life, guys. 10.0, we should talk. 9X. Had the same session yesterday. Nobody raised their hand on 10.0 or 9X. And it's the first time that has ever happened. Every single attendee was on a supported version. Thank you, everybody, for upgrading. I truly appreciate it. We put out these new releases, lots of enhancement, bug fixes, new capabilities. I strongly encourage it. 10.5 release, I know we say this all the time, but it's certainly true. 10.5 release is by far the best release we've ever had. Now 10.5.1. There's a lot of new things, and go check out the doc for it. All right. So once you have this base deployment in place, what can you actually do? What functionality do I have available? Well, like I said, you have everything you have always had with ArcGIS Server. All the traditional server functionality is still there in exactly the same way as before. Might have slightly different wrapping in certain respects, but all the functionality is absolutely there. You can publish your map services, your feature services, referencing your data coming from file-based data sources, your enterprise geodatabases by reference, meaning you're not copying the data over to the system. You're saying the data's over here, leave it in place, publish a service. That's still there, it's not going away. We're not trying to push everybody towards this hosted model. That's an alternative, an additional option for certain workflows. So you can still publish all of those geoprocessing services as well, and routing, whatnot. But then you also have the ability to do self-service mapping. Offer your users within your organization the ability to go to the portal itself and simply do their own mapping in many cases, using your layers, your content, as well as whatever they're adding to the system. Doing mashups you haven't even thought about, and instead of having to call you in the GIS department or your colleagues in the GIS department, as it may be, they can do a lot of those things on their own. They can create their web maps and be very productive in that way. And of course, you have a whole lot of new options for creating applications based on those web maps. Story maps, configurable app templates. Going further down the spectrum of unconfigured things, you have Web App Builder for creating more custom applications. New in 10.5.1, you have custom widgets within the Web App Builder inside of the portal itself. You don't have to go out to the developer edition anymore. And then, of course, you have the raw APIs and SDKs if you want to write your own applications from scratch. There's lots of use cases for that. And all of that builds on top of the base deployment and can take advantage of the portal, security, identity model, groups, sharing, and so forth. All of that builds on top of the base deployment. So the super quick version of setting up the base deployment in 3 steps. Vastly oversimplified, of course. Otherwise, why am I here talking? But you can think of it like this. Configure the web adapters. You've already laid down the bits on disk. Now configure the web adapters with their respective components. Take the data store, register it with the server, and take that server and federate it with the portal. And then once you've federated, say to the portal, by the way, this is your hosting server. It's a very special type of server. It seemed pretty easy, right? Well, we have gotten some feedback, I would say, that that's not always quite that easy. There's a subtle prerequisite I didn't even touch on here. You have to have your SSL certificates. I'm sorry, I cannot fix that one for you. If I could, I promise you I would. It is by far the thing we get the most feedback on from customers is that what are these SSL certificates? How do I get them? Why? And I can't solve the how. I can tell you the why because that's simply the direction everything on the web is going for. We need to have a secure system. The browsers themselves are becoming incredibly restrictive about things that are not on SSL. There's certain features that get turned off. We need to have this in place. Don't use self-signed certificates. Just don't. It won't work very well. You'll get weird error messages all over the place, and you'll blame me, and I really don't want that to be the case. But if you need to get CA-signed certificates from VeriSign, DigiCert, whatever it is, you need to figure that out with your IT departments through your processes. If you have an internal certificate authority that your organization trusts, I can't help you with the process for getting those certificates. That's something that sits outside of the system, but it's a hard prereq. It has to be in place. You can't even set up the system without it. The part that we can do something about is the initial installation. And you saw Julia do a segment on this during the plenary on Monday. She talked about the new ArcGIS Enterprise Builder that we introduced at 10.5.1. Talked about Chef for doing more advanced deployments. She talked about this cloud tooling for AWS and Azure. And I'll get back to all of those different things. But in the meantime, I will say one thing, and I'll make a bold statement. What I want you to come away from this session thinking is, if I'm installing the software by hand, I'm doing it wrong. I want you to use the tools that we provided. It is by far the easiest way to do this. That doesn't mean you can't do it by hand. We've all installed the software by hand. And I think it's very valuable, especially for you as IT administrators, to have done that at least once or twice. So you understand the processes that are going on behind the scenes. When you're doing troubleshooting, when you need to understand the different components, that's invaluable. But for your production deployments, use one of the tools that we have that simplifies this process, whether it's the Builder, whether it's Chef, or some of the cloud tools. In the documentation, we have a tutorial for doing the base deployment by hand. Walks you through all the different steps, and it talks you through doing this on a single machine. All of those components on one machine. We'll talk about, do you want to do it on one machine or not, but that's the tutorial, that's the initial setup. So again, please go and use the documentation, go through this on your own. Now, let's get to the meat of things. I've already talked for half an hour, and now we're getting to the good stuff. The first choice that you will have to make, other than wonder why my animation is off, is to figure out that exact thing that I just mentioned. Do I want all of my software components on one machine, or do I want a multi-tiered deployment? Do I want to split the software components up on different machines? Why do I want to do that? Do I need to scale? Do I have policies that simply say, no, I heard this thing is a database. Databases must be on their own machines. It's just an IT regulation. We've heard that one. Whatever the reason is, you need to think about the purpose for splitting things apart and then figuring out what the right pattern for you is. I will say that a single machine deployment or an all-in-one deployment is a very effective way for a lot of different systems that don't have super high requirements for concurrent use, for high availability, and so forth. Don't overthink this. If you were happy with a single machine ArcGIS Server in the past, there's no reason that you need to go out and think, wow, I need at least 3 machines for all this stuff. If you were happy with a single machine in the past, you should be happy with a single machine here. Might have to be a slightly bigger machine, at least a little bit more memory, but you can absolutely have a well-functioning production system on a single box. If you do need to scale out because you have a lot of users or they're doing a lot of analysis, that's what we'll talk about next, and trying to figure out how to make that determination. So let's take these 3 tiers in order. You can think of Portal for ArcGIS as being your web tier, ArcGIS Server being your app tier, that's the back-end processing where stuff happens, and then ArcGIS Data Store is your data tier. That's where data ultimately gets stored. So let's take those one by one. Well, when do I need to scale Portal for ArcGIS? My answer is rarely. And then, of course, there's lots of caveats to that. Portal for ArcGIS is not a very heavyweight component by itself. It uses a decent amount of memory, but once it's taken that initial amount of memory, it doesn't do that much resource consumption-wise. You might see CPU spikes every now and again as somebody searches for some crazy broad term across a portal that has hundreds of thousands of items. But other than that, Portal for ArcGIS itself doesn't need that many resources. Portal for ArcGIS also doesn't scale across multiple machines. So if you do monitor your system and find yourself needing more horsepower for some reason, the way to scale Portal is to get a bigger box. It's not adding more machines. That's different from ArcGIS Server, right? Now, Portal does support a 2-machine setup, but that's for the purposes of high availability, not for scaling. You get a little bit of scaling with that as well, but that's not the primary purpose. The purpose of the 2-machine setup is to protect yourself against, if one of those machines goes down, there's still another one to take over. It's not to scale. For that, get more memory. Hopefully you're in a virtualized environment of some kind and it's just flipping a switch somewhere. Otherwise somebody will have to come and give you a memory stick and you'll have to put it in. That's the easy one. Now, when we talk about ArcGIS Server within the base deployment, remember I mentioned it's doing double duty. It's doing everything that your ArcGIS Server did in the past. Classic, traditional map services and feature service and all those other things. But it's also now the place where analysis is run. If somebody goes into the portal map viewer, clicks the analysis tab and says, do a join features, new tool at 10.5.1. Well, where does that analysis actually take place? Where does the compute happen? It happens on the hosting server. So now all of a sudden this machine is doing essentially geoprocessing jobs in addition to everything else you might be running on it. So the first way to scale out your base deployment might actually be to say, well, I want to have a dedicated ArcGIS server site for the purposes of my traditional services. I don't want to commingle my map services and all those production map and feature services that I have with all that newfangled hosted analysis and whatnot. I want to have dedicated infrastructure for that. And you should do that. That's a very, very good way of doing what we call workload separation. Different workloads on different pieces of infrastructure. So that's one way to separate things out. Now, if you need to scale the hosting server site because you don't want to have a separate site for all those other things, or simply because those functions, the analysis tools and so forth that I mentioned, that they have outgrown the single machine that you had in the initial base deployment, well, you can do one of two things. You can, of course, get a bigger box. But ArcGIS Server has always supported the idea of adding more machines, and in this case, not just for high availability, but also for adding capacity. Adding a second machine, a third machine, however many it might be. Take questions at the end. So you can do that. That's an option for both the hosting server side and any other ArcGIS server side that you have. So why would I need to scale out? Well, I mentioned the analysis tools, but one particular thing that I want to highlight is Insights for ArcGIS. Insights was a new application at 10.5, right? Well, Insights does its analysis on the hosting server as well. So that's an example of an application that by itself can drive a lot of new computationally heavy processing on that hosting server site. So keep that in mind. If you're looking at Insights, that's something to monitor for. And at the end of the day, all of these things come down to monitor for bottlenecks. I can't predict how many users you have, their exact workloads, and so forth. You need to monitor for memory consumption, CPU, all those traditional tools. All right. This is probably my most text-heavy slide. It's not because I want to have text-heavy slides, but I was trying to get a lot of information on here, and I wanted you to be able to take this information when you go back home and have it as a reference. So let's talk about ArcGIS Data Store. First, remember there's 3 different types of data stores: relational, tile cache, and spatiotemporal. We'll focus on relational and tile cache for now. Relational, again, as you remember, this is where data goes when you're doing analysis, when you're copying data to it. And just like with Insights, when it's doing the analysis itself, what Insights actually also tries to do in many cases, if appropriate for the types of data and the data sources that you're working with, tries to push a lot of the analysis down to the relational data store. You can do a lot of joins and things like that much more efficiently at the database level. That's something to keep in mind as well. Beyond that, the relational data store is used essentially when somebody is requesting data from a hosted feature layer. And one of the interesting things to keep in mind, and this is again where I can't make a general pronouncement, is imagine you have 1,000 hosted feature layers, or 10,000. There's a very different resource consumption pattern between random requests scattered across the entire set of hosted feature layers, 1,000, 10,000, versus a lot of users hitting a very small subset of those hosted feature layers. Generally, we see the latter. It's much more common to have lots of old data sets that most people are not using, but a few of them are hot because a lot of users end up requesting data from them. So that's what we've optimized for. What you need to look at is if you are seeing a lot of CPU consumption at the relational data store tier, that's an indication you need to scale out, and probably because your users are hitting a bigger combination of these hosted feature layers that you have in there. Or maybe you have insights and they're doing a lot of analysis. The tile cache data store is kind of interesting. 3D tile caches are created in a similar fashion to traditional cache map services. When you copy the data, whether it's multi-patches or whatnot, to the server, you're publishing a new scene layer. We build the visualization cache behind the scenes. So at the time of publishing the scene layer, you'll see a spike. That's where it uses a ton of CPU on the hosting server, and the tile cache data store itself is ingesting all of this data. And then it goes way down. It's done, it's created this cache. And from then on, it's really just returning, streaming data back from the cache itself. So that's where you start seeing a little bit of I/O maybe on the tile cache data store, but not a whole lot of anything else. Maybe some memory to internally cache. So at the end of the day, monitor again. I can tell you the different metrics to monitor for, but ultimately it depends on your users and their workloads. Remember, it's not just CPU and memory, disk I/O. If you can get an SSD for your data store, do so. It matters. We're writing data to and reading from disk. The faster, the better. Now, one small detail that I'll point out here because I think it's worthwhile is that when I talk about monitoring for bottlenecks, I also want you to monitor other things. For example, running out of disk space. That is a surprisingly common occurrence. Whether it's because of log files that don't get deleted or you're simply getting more data than you expected and planned for, backup files on disk, automated backups that aren't being cleaned up or moved away. We've seen a number of cases that have come in through Esri tech support where customers ran out of disk space. That's not a very good situation. The slight twist on it was we also did not handle that very well because, well, we didn't expect to run out of disk space. So pre-10.5.1 versions of the data store, you could get into some trouble there. Please don't get into that kind of trouble. If you do, call Esri tech support and they can help you get your data store back into a functioning state after you've added more disk space. At 10.5.1 and higher, what you'll see is that we will go into a graceful degraded mode. The relational data store will go into a read-only mode once your available disk space drops below, I think it's 2 gigabytes. You will start seeing certain operations fail. Now you can no longer perform analysis, but you won't corrupt your data store, so that's a plus. So be aware of that, and here's another reason to upgrade every now and again. We do make these kinds of low-level improvements. At the end of the day, though, please don't run out of disk space. So that's a very quick overview of the base deployment itself, the different tiers and things to consider. So how do I scale beyond that? Well, let's take a look at that, and I'll make a couple of points before getting started. You can have any number of ArcGIS server sites federated with your portal. As many as you want, for different purposes. That's a common misconception that I hear. You're not limited to one ArcGIS server site. You can have many. And the next one is essentially what I said at the beginning. You have a single ArcGIS Server software component, but depending on what capabilities you're using, they behave in very different ways. The GIS Server, publishing map services, is very different from running GeoAnalytics. We'll talk about what that means. But that also means you can't just make a blanket statement that, well, ArcGIS Server behaves in this and that way. Well, you're probably thinking of the GIS Server, and that's fair. We named it like that. All right. So I covered this a little bit already. The two main things to keep in mind is you can have as many GIS Server sites as makes sense for your deployment. If you want to split out heavyweight geoprocessing services and make sure that they don't trash all your important map services, separate sites for those two things. Hosting server, separated out from other server sites. And then there's scaling out from the base deployment because you're adding additional capabilities altogether. So that's GeoEvent, Image, and GeoAnalytics. So the GIS server. I just have one slide because I've said it. I want to repeat it. You already have one. There's already a GIS server as part of the base deployment. If you don't need to, you don't have to add additional GIS server sites. This is your traditional ArcGIS server that does everything you've had before plus more. There are some specific reasons that we often see, whether it's workload separation or things like SLAs that are different. These map services are super important. They have to have, I don't know how many nines worth of uptime. Great. This server site gets special treatment. And then there's my ad hoc server site. It's where people publish random stuff. Important, but short-lived, who knows. It's not something we care that much about. Completely different SLA. Different machines so they don't stomp on each other. And if that slightly less important site goes down, we have a few hours or a few days to get it back up and running versus the other one. That one just has to keep going. But let's move on to the additional capabilities that we can add to ArcGIS Enterprise. The first one that I'll talk about is the Image Server. So first, let's talk about what Image Server is. Remember, this used to be Image Extension. Now it's Image Server. So Image Server does everything that the Image Extension did in the past. And what was that? In a nutshell, that's dynamic image services off mosaic data sets. Right? Doing on-the-fly processing, whatever the fancy raster functions and raster models that you apply, being done at display resolution. Just like a map service, you pan around and it draws something, returns it to you, and it's ephemeral. That image never gets saved anywhere. But it's really fast on-the-fly processing. New at 10.5 is what we call raster analytics. Instead of dynamic image services that do on the fly and then doesn't store the result, but it's doing it really fast at display resolution, raster analytics is about being able to apply those same raster functions and raster models that you build and then apply them to an entire mosaic data set, large volumes of imagery, whatever it might be, and then persist the result. And doing all that processing at source resolution. It can be things like I have 1,000 rasters, 1,000 images, and then apply this model and create 1,000 new derived ones and store them somewhere on disk, cloud storage, whatever it might be. So those are two different capabilities that are both part of Image Server at 10.5 and 10.5.1. You can have any number of image server sites doing dynamic image services, the traditional image services that you've used in the past. Just like before, you can split them into multiple different sites, different service levels, different groups of services if you need to. On the other hand, raster analytics follows the Highlander model. There can be only one. When you submit a job, when you tell the system, please go off and process this raster function chain and apply it to these rasters, it follows kind of the model of a GP tool, but it goes to a site, a specific site. Just like there's a hosting server, that site has a special purpose. You designate one of your potentially many image server sites and says, this is where raster analytics jobs go to be processed. So if we look at our deployment, we've got our base deployment, the web adapters, the portal, the hosting server, the data stores, and then one option is to add an image server site. One or more machines in that single site. Another option is to potentially split raster analytics off from my dynamic image services. Because raster analytics is about distributed computing. It also takes advantage of all the cores on your machine, all the machines in your site, to do things as quickly as possible. There's an entire session on that that I'll mention here in just a second. But that means it tries to use all of the available resources when it's doing its job. You probably don't want to commingle that with your image services. They're not going to run very fast while you're doing all of this other processing. So you can start splitting things up like this. Now, one detail from the previous slide is that at 10.5x, 10.5 and 10.5.1, the results of your raster analysis will itself be hosted as a new service on the same raster analytics site. That'll likely change in future releases. In the future, we intend to give you the ability to say, well, the result gets hosted off a service coming from this other site, specifically to avoid results being commingled with future processing. But at 10.5, 10.5.1, do note that that's the case. So if you want to know more, you're in luck right after this session. You didn't miss it. So raster analytics in image server here at 315 in room 15B, so just down the hall. Now let me move on to GeoAnalytics Server. GeoAnalytics Server is brand new at 10.5. This did not exist before and is quite fascinating. It's a topic that I very much like to talk about, but I won't get into the details of what it does too much. Again, there's other sessions for that. What I want to talk about is the architectural implications. GeoAnalytics Server is about processing large volumes of vector and tabular data, spatio-temporal data, if you will. It requires the spatio-temporal big data store. When you're processing large volumes of data, even if you're doing aggregation, the output, the results, have a tendency to themselves be fairly big. So we need a data store type that can handle large volumes of data and that can handle large volumes of data being written really quickly. That's not a traditional RDBMS. So that's where the spatial-temporal big data store type comes in. So you need to add that to your base deployment in addition to a GeoAnalytics server site itself. Now, one of the most common questions that I get about GeoAnalytics is, well, how many machines do I need? That's a great question. I wish I could answer it for you. What I can do is tell you the variables that you need to consider, because there is no one single answer. Happily for all of us, your system architects, you have a great job here. We're not trying to put you out of business by any stretch, and we will not succeed if we tried to. There's so many different variables that go into this that it's very hard to make a general pronouncement. But the one thing I can definitely say with certainty is that don't fall into the trap of thinking that more cores equals faster processing. The opposite can very much be true, as counterintuitive as that might seem. And why is that? Well, here's just some of the variables that you need to keep in mind. First, what's your definition of big data? Everybody has a slightly different perspective on what big data is. Mansoor Raad, good colleague, who was on stage at the plenary on Monday doing some demos, has a semi-famous saying within Esri, that big data is in the eye of the beholder, essentially. Big data is whatever is too big for your current tool set, whatever that tool set is. If you can't reasonably process it using your existing tools, then it's essentially big data. It's too big for what you have. So big data doesn't necessarily have to mean billions of records, terabytes worth of data. It can be much smaller than that. So don't think that GeoAnalytics is necessarily just for, well, I don't have a billion data set. Maybe I have a few tens of millions. If you've run a geoprocessing job within ArcMap or Pro and crossed your fingers that you didn't get an error 999 before it finished, you have what is essentially big enough data. So that brings in an interesting perspective. Do you have a few hundred megabytes worth of CSV files? Do you have 100 gigabytes worth of CSV files? Do you have a large enterprise geodatabase data set? Do you have data coming from HDFS, from Hive, all of these different data sources? Well, that matters quite a lot for the performance. Are you reading local data? Are you reading data from a file share with low latency? Or are you reading data from somewhere in cloud storage with relatively high latency? That matters a lot, because one of the key things is keeping all those CPU cores busy. If we can't read the data fast enough and get it to those cores, it doesn't really matter. Cores are just sitting there idle. You can throw all the machines at it that you want, but you can't actually get the data there fast enough. If your data set is not that large, having many machines, many cores might actually work to your disadvantage. Because now we're doing all this work with all this overhead of splitting the data up into tiny little chunks. And the overhead of splitting it into chunks and then stitching the result back together outweighs the actual performance benefit of splitting it in the first place. So there's these odd curves of adding more cores, and then all of a sudden the performance drops off a cliff when you add an additional machine, which seems oddly counterintuitive, but starts making sense when you look at these many different variables. You need to remember to keep enough memory per CPU core. It's not just about getting the data to the machine, it's also about keeping that data in memory on the machine itself. If we can't keep it in memory, again, those CPU cores are going to be sitting there idle, doing nothing. It's the right ratio. And all of this depends on what tool you're running, what jobs. Long story short, you need to prototype this out. You have to look at your data, your users. Are you looking to have one job running at a time really quickly, as fast as it can? Or are you trying to support many users running ad hoc jobs and running them concurrently? That's very different as well. If you're trying to run concurrently, you don't want the jobs to step on each other and affect performance. So, what does it actually look like? What's the logical diagram for setting up GeoAnalytics Server? Well, the minimum for GeoAnalytics Server is going to be essentially 3 machines. And all-in-one with your base deployment, the 4 software components from before, your web adapter, portal, hosting server, and your relational tile cache data store. 1 machine. 1 additional machine for the spatial temporal big data store. You definitely want that on its own separate dedicated machine. And then a 3rd machine for the GeoAnalytics Server. That's the bare minimum. But that can also be very, very effective for a lot of different workflows. Again, it doesn't have to be hundreds of cores, hundreds of machines, terabytes worth of data. This by itself on 3 machines can actually do a lot of things that traditional GIS analysts will find very valuable. One example was taking a CSV file. CSV files are the shape files of the big data world. It's actually quite brilliant. I find this incredibly amusing. So as a test, at one point during the development cycle, I went to an open data website and downloaded a data set with 6 million points in Chicago, 1.3 gigabyte CSV file. The kind of thing where, you know, if I bring this into Pro or ArcMap and say create an XY event layer, I'd probably be waiting a while. Wouldn't quite know what to do with myself while that was processing. Instead, I aggregated it into the census block groups in Chicago on literally the machines sitting under my desk and a colleague that I co-opted for this purpose, and ran the processing in 1.5 minutes. Is that big data? Well, maybe not. It was certainly big enough that I wouldn't have wanted to use my traditional tools. So this can be very effective. And you can scale from here. You can go from the 3-machine deployment to adding as many GeoAnalytics Server machines as you need. Remember, there's a single site, but you scale that site out with n number of machines. Remember, enough memory and enough cores on each one of the machines as appropriate. And then remember to also scale the spatial temporal big data store at the same time. You have to scale the data store so you don't run into the situation where all of a sudden you have a lot of data being processed and generated, but we can't store it fast enough. The output can't keep up with all the processing that's going on. So you have to scale both of those things at the same time. If you want to know more about GeoAnalytics, well, you've already missed one session, but fret not. Tomorrow, there's another repeat of the GeoAnalytics Server intro session. So if you're interested in this, I piqued your curiosity with that CSV file sample, definitely do go there. All right, GeoEvent Server. GeoEvent Server has been around for a while. Used to be GeoEvent Extension, now Server. It does real-time processing, ingesting real-time data streams that come in, do some processing, alerting, notifications, whatever it might be, and then archiving the data out for posterity, and also streaming that data on for visualization. The GeoEvent team wants me to stress that at 10.5.1 and prior, also prior releases, they recommend using single machine sites. That means that your individual GeoEvent Server machines have to be able to handle the peak load of whatever streams are assigned to it. If you need to handle more streams than what you can do on a single machine, set up a separate site. If you have enough data coming in that your traditional enterprise geodatabase can't keep up, then you can add the spatial temporal big data store for archiving. Traditional RDBMSs generally top out at around 200 to 300 to 400 events per second. Features being written per second into the RDBMS. This is traditional SQL, Oracle, Postgres type databases. So if you have 1,000 events per second coming in and you want to archive that, you need something different. That's where the spatial temporal big data store comes in. That's its purpose in life, archiving all that data. It's also when you've run GeoEvent for a long while, maybe for a year, if you're ingesting 1,000 events per second for a year straight, now you've got big data. You store that in the spatial temporal big data store, and you can do all kinds of analytics on it. For example, using GeoAnalytics. So the minimal way of getting started with GeoEvent is, again, you have your base deployment and add a GeoEvent server site. You can start it with one machine in that one site. Even with a single GeoEvent server, you can process, depending on the type of analytics you do on it, somewhere in the range of 3,000 to 6,000 events per second. Way more than the 200 to 400 events that a traditional database can keep up with. So if you have that, add the spatial temporal big data store. And then you get to figure out, do I need one node? Do I need multiple nodes? All depends on your data sets. If you need to scale out further, then again, the recommendation from the GeoEvent team is to use individual server sites, one machine per site. GeoEvent does support having multiple machines in a single site, but we've had enough reports of trouble in the wild that we recommend single machine sites to avoid that. If you have a multi-machine GeoEvents set up, you don't need to change if it's working for you. But to avoid problems, we recommend single machine sites. To learn more about GeoEvent itself, there's also sessions for that. One was yesterday, you missed it. One is tomorrow. You can go and get much more information about the functionality of GeoEvent and some details on this piece. All right. This is really more of a recap slide. It's the cheat sheet that hopefully will become valuable for you when you go back. Some server roles lend themselves to multiple sites. Other capabilities, less so. Raster analytics and GeoAnalytics, Highlander. Everybody took pictures. Business cards, I'll send you the slides. So now we've talked a lot about the individual software components, how they fit together, things to keep in mind. I want to touch on the deployment aspect just a little bit more because I find it's really important. And you're the same people in many cases who won't just be drawing the pretty icons and the lines, but also having to work with or do the deployment yourself. So remember what I said. It's not that I don't want you to install by hand ever. I think that's a valuable experience. But if you do that on a regular basis for production, staging, or even dev test style environments, I think you're doing it wrong. There are better ways of doing it. The ArcGIS Enterprise Builder that Julia showed on stage Monday is new at 10.5.1 and sets up the all-in-one deployment for you. Installs the web adapters, the portal, the hosting server, relational tile cache data stores on a single machine with a minimum of fuss. You literally answer something on the order of 5, 6 questions, click next, next, next a few times, and then finish. You walk away, go have lunch, come back. It's all done for you. Every single step except one. Which one? SSL certificates. I'm sorry. I promise we would solve that if we could. You have to have the SSL certificates in place before you click next, 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 finish. Once you have that, though, it takes about 45 minutes, 30 to 45 minutes. Everything's done. It's federated, set up as your hosting site, all that stuff. You don't have to remember the distinction between your admin URL and your services URL, and what am I even talking about? For any kind of single machine, all-in-one deployment, use the builder. Unless you're running in the cloud. How many of you here in the room use AWS or Microsoft Azure? Good amount of you. For those two cloud environments, we have specialized tooling. It makes it even easier. In AWS, we have CloudFormation templates. Use them. One of the templates is the single machine all-in-one base deployment. Click, and not just installs the software and does the configuration for you, but it also spins up the AWS infrastructure, your EC2 instances and all that stuff. ELBs, all good things. For Microsoft Azure, we have a cloud builder. It's a wizard-driven interface. You say exactly how many machines you want at each tier, the instance type, size, and all that stuff. Again, click off. At the very end, after you give us access to your SSL certificates, click finish, and it deploys everything for you. Before the UC, I spun up a 5-machine deployment with GeoAnalytics, a spatial temporal big data store. I spent about an hour as a hobby while doing email. You cannot do that by hand. Don't even try. It's not fun. If you're running a more advanced deployment, you need multiple machines, you need to do workload separation, you're running in a bare metal hardware, virtualized hardware, or maybe even other cloud environments that we don't have specific tooling for, Google Cloud, IBM SoftLayer, lots of different ones, use Chef. Even if you're not doing a lot of repeated deployments, Chef is great for that because you can have the same run list. You know exactly what's going to be set up every single time. But even if you're not doing repeated deployments, Chef has the advantage of being infrastructure as code. When you go back 6 months later, or somebody else goes back 6 months later and asks, what did you deploy? You can simply point them to the Chef run list. I deployed these software components that did this, this, and that. It takes away the element of human error. Again, what was the admin URL versus services URL? It's all documented here. Chef is itself an open source automation framework. It's free to download. You can use it. And it even has a more even fancier paid offering that you can use as well. So I highly recommend using one of these 3 options, whichever one is appropriate for you. Please stop doing hand installs. You'll call me when something goes wrong. Nobody wants that. Least of all me. I'll finish off on just a couple of other topics. They're slightly outside everything else I've talked about, but they still relate to architecture, and I'm willing to bet that many of you will find some of this information a little bit interesting. So here we go. Common myths and updating best practices. Don't use siloed sites anymore. Siloed sites is this idea of having single machine ArcGIS Server deployments with the same set of map services or whatever services, and you put a load balancer in front and you make it all look like one single instance. It's a very powerful deployment pattern, has a lot of advantages for things like management, but it doesn't play nicely with the federated model, having a portal where your ArcGIS Server site is federated with it. That means this pattern doesn't work in the new ArcGIS Enterprise deployment model that I just talked about. And besides being a hypothetical, well, that's nice, but I know what I'm doing, Philip. You're missing out on ArcGIS Pro publishing, as an example. You're missing out on all kinds of new functionality that depends on the federated model. Second one, do not use clusters anymore. How many of you have multi-machine sites where you've used clusters to split the site into multiple parts? Clusters are now officially deprecated as of 10.5.1. I wrote the deprecation notice myself. I want you to stop doing it. We introduced what we call single cluster mode at 10.3.1. It was an option you could turn on. At 10.4, we made that option the default. If you upgraded from a site that only had a single cluster, the default cluster, we turned on single cluster mode behind the scenes and you never noticed, besides the fact that things were a little bit more stable, a little faster in many cases. But if you upgraded with multiple clusters in place, we didn't touch it. We would have broken your site. We don't like to break people. At 10.5.1, we're now officially telling you they will go away in a future release. When they go away, I'm not saying when yet, I'm giving you a heads up. When they go away, you will not be able to upgrade if you have multiple clusters. So we want you to give you enough time to start changing your deployment pattern before that happens. Again, I have no interest in trying to break anybody. In fact, that makes me very sad. Do federate your ArcGIS Server sites for all of the reasons that I just mentioned. Do use the web adapter, unless you have a very good reason not to. But Philip, you say, I have a very good reason not to. I don't believe you. We can have a conversation. I'm a reasonable guy. You can try to convince me, and you might succeed. But as an initial starting point, I don't believe you. And the reason is simply that the web adapter simplifies a lot of little details that you otherwise have to do by hand. So instead of trying to remember to set up web context URLs and all of these little details that you have to dig out of the documentation, it's all there and it can be done. Why not just use the web adapter? If you have fancy F5 hardware load balancers or you love your Engine X's in your DMC or whatnot, it's okay, you can still continue to use those too. Put them in front of the web adapter to make all of our lives easier. If you really know what you're doing, it's okay, I'll buy you a beer and you can do it by hand. Two other things that I want to mention because they're kind of quirky, but if you do run into this, it's good to know. I'll start from the bottom on this one. With the 10.3x series of server, for lots of reasons I won't get into, we had a hard limit on the number of SOC instances, service instances you could run on a single machine. Didn't matter how much memory you had on there. Could have a terabyte worth of memory. We maxed out at 250 service instances, not services. If you had 100 services and you ran 3 instances of each, you would have 300. The last 50 would fail to start and you would be upset. It's not an issue with 10.4 and higher. If you're on Linux, rejoice, it just works. Worth noting. On Windows, there's an interesting thing. Again, the hypothetical 1 terabyte machine. Lots of CPUs, tons of memory. And then once you start having about 250 SOC processes, service instances, again, good old-fashioned SOCs, you start getting failures to start new services. You look in the logs and it complains about being out of memory, and you check the physical memory, you look at the swap file, all good. What in the world is it talking about? The non-interactive desktop heap is a phrase you never want to hear repeated again. It's a Windows limitation. We're using resources from the non-interactive desktop heap, and the non-interactive desktop heap happens to be limited by default in Windows. Modern versions of Windows have a slightly higher limit than previously, but nonetheless there is a limit, and it's not tied to the amount of physical memory on your box. Thankfully, you can lift this limit. It's not an ArcGIS Server limitation. You simply edit the Windows registry. Yes, I said simply edit the registry. It is by far the most arcane Windows registry setting you will ever find. I am not kidding. We've documented this in a tech article. I mention it because with machines getting bigger and bigger, we're starting to see more and more customers run into this. So instead of you having to pull your hair out, wonder what's going on, call tech support, remember that I mentioned this to you. If you've ever run into it, go to the support website, and hopefully you will find this tech article. Walks you through changing the Windows registry. Once you do that, you can publish as many services as you have resources to support on the box. If you have a terabyte, knock yourself out. All right, I'm at my time limit. My takeaway, stay up to date on best practices. They do change over time. What was a best practice at 10.2 may very well not be at 10.5. Enterprise is designed for the federated server model. All of our newer functionality, including very core things like publishing from ArcGIS Pro, depends on having a portal and federating your servers with that portal. Understand the base deployment. That's really the nucleus of everything. And then understand the different server roles. They're all subtly different from each other. And then remember what I started off by saying. Don't panic. We'll get through this. Thank you so much for coming. Please go to the Events app, fill out the survey, tell them all about my bad jokes. It wouldn't be the first time. If anybody's interested, I'll be up here. I'll take some questions. If you want the slides, come put your business card, and I'll get them to you. Thank you very much.